Ow.
Hello dear students, today we are going to see our science part first, gravitation. In this first lesson, we are going to see about Sir Isaac Newton, who was born in England in 1642 to 1727. So, in a form of short story, we will see first.
Today, I'd like to introduce you to Sir Isaac Newton. Sir Isaac, this is Bob.
Is he ignoring us?
He's an important man. He's got a lot on his mind.
He's the genius who invented gravity, right?
Well, he discovered it. He didn't invent it.
Where did he discover it?
You see, stay with me here. Newton was a great mathematician and inventor. He was determined to solve the mystery. Why do planets stay in orbit? What's stopping them from flying off into space?
It's gravity.
I knew you'd get it. It's gravity.
Obvious, really.
Obvious now, but not back then. Back then, there was no reason to assume that the force that holds planets in orbit is the same force as the one that holds us down here on Earth. That is the work of a genius.
I'm not sure if I get you. But carry on.
The story goes that one day, Sir Isaac was puzzling away, thinking about the planets, while sitting under an apple tree. The apples are ripe, and then do you know what? One falls on his head.
Ow! Not good.
But it was good. It gave him his big idea, and actually we don't know for sure that it even did fall on his head. Maybe it just fell beside him. So Newton watched the apple fall, and he thought about the force pulling it down to the ground. And then, with a leap of mind, as befits your regular genius, he realized it's also gravity that pulls on the Earth and prevents it from leaving its orbit around the sun.
Can you just repeat that bit?
Okay, why does an apple fall to the ground, and why does the Earth not fly off into space?
You know, I think maybe I'm not a genius, because I'm not sure of the answer to that one.
Bob, you literally just gave me the answer 20 seconds ago.
I did?
Newton loved puzzles. In his younger days, he was the sort of fellow who leans into the wind with his coattails out to see how far he could lean before he fell over.
Yeah? I also tried to fly once, and I was using nothing but sheer physical willpower. I really feel like I might be a genius too.
Ah, but Bob, he wasn't trying to fly. Jump forward many years. Newton is now a grown-up, and he continues to be fascinated with the way things work. We see him here, hard at work, observing and thinking.
Yeah, I can see that. But what's he thinking about?
He's thinking about the planets. You see that little dot up there? That's one of them. He's thinking about the planets, and he's wondering why they're moving around the sun. You see, the Earth is a bit like a tennis ball on a string. It's going around the sun.
Gosh, that was cool. How did you do that?
Well, we're in a cartoon, aren't we? We can do what we like. But that's the point, you see. Newton lived in the real world. He knew that there had to be an actual force holding the planet in its orbit. You see right now? There he is, spinning the ball, and he's pulling on the string. If he's not pulling on that string, watch what happens. You see? No pulling force, and it's bye-bye planet.
Gosh, that's kind of astronomical, isn't it?
Astronomical. Good pun.
Pun?
Okay,
Oh, I see. It's gravity.
thank goodness. Okay, so here's the next bit. You see, something else you need to know about Newton is that he believed in God. So he didn't think these forces just happened to be there. Newton believed that everything in the universe exists because of God.
Yeah, that makes sense. Gravity, invented by God. I like that.
Exactly. So in Newton's view, gravity is God's idea. And that's what Newton found so impressive.
Gravity, worth waiting for. Get it? Wait.
Very good, Bob. You really are paying attention. Okay. So, Newton's thinking, God is great. God is ingenious. If God's going to invent a force to stop planets from leaving their orbits, it's going to be...
I know! Gravity! Newton's idea was that God is the creator of the universe, and God came up with gravity. And so gravity. It holds the Earth in its orbit, and it pulls an apple to the ground. Why invent two forces when one will do?
That's actually quite well said. Well done, Bob, thank you. I couldn't have said it better myself. And that's the end of the story. That was the way that Sir Isaac saw science. Sir Isaac believed that God intends us to be curious and to investigate the world around us to understand it better. And the more Newton found out, the more new questions he thought of to ask. True genius.
Yeah, it's good. Genius. We haven't explained everything. Like, for example, what happened to the apple? Do we know what happened to the apple?
Actually, I don't think we do.
That's what I thought. Says it all. You solve one mystery and before you know it, the next one comes along.
Yes, Bob.
Gravitation. As we have learned, the phenomenon of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fall off in a horizontal direction? After much thought, he came to the conclusion that the earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is the vertical direction at the position of the apple, and thus the apple falls vertically downwards. Newton thought that if the force of gravity acts on the apple on the tree at different height from the surface of the earth, it can also act on the object at even a greater heights. Much further away from the earth, like the example, the moon. Can it act on even further objects like the other planets and the sun? अभी हम सर न्यूटन के बारे में देखेंगे. सर आइजैक न्यूटन, he was born in 1642 to 1727, was one of the greatest scientists of recent time. He was born in England. He gave his laws of motion, equations of motion, and theory of gravity in his book Principia. Before this book was written, Kepler had given 3 laws describing planetary motion. However, the reason why planets moves in the way described by Kepler's law was not known. तो उसके बाद क्या किया न्यूटन ने? वो डिराइव किया. न्यूटन with his theory of gravity mathematically derived Kepler's law. जो तीनों लॉज थे वो क्या किए? उसने डिराइव किए. In addition to this, Newton did ground breaking work in several areas including light, heat, sound, and mathematics. He invented a new branch of mathematics. This is called the calculus and has wide-ranging applications in physics and mathematics. If you see, he was the first scientist to construct a reflecting telescope. Now we will see our next point, that is the circular motion and the centripetal force. In that the activity was given, try this. In that, see, tie a stone to the one end of a string. Take the another end in your hand and rotate the string so that the stone moves along a circle. Are you applying any force on the stone? In which the direction is this force acting? How will you stop this force from acting? What will be the effect on the stone? Can you guess? Yes. As long as we are holding the string, we are pulling the stone towards us, that is, toward the center of the circle, and are applying a force towards it. The force stops acting if we release the string. स्ट्रिंग रिलीज की तो फोर्स वो स्टॉप हो जाता है. In this case, the stone will fly off along a straight line which is tangent to the circle as the position of the stone when the string is released, because that is the direction of its velocity at that instant of time. You may recall that we have performed a similar activity previously, in which a 5 rupee coin kept on rotating in a circular disc flies off the disc along the tangent. Thus, a force acts on an object moving along a circle and it is directed towards the center of a circle. This is called the centripetal force, और इसी को centripetal force कहा जाता है. Centripetal means center seeking, that is, the object tries to go towards the center of a circle because of this force. You know that the moon, which is natural satellite of the earth, goes around it in a different orbit. The direction of motion of the moon as well as its speed continuously changes during this motion. और ये मून का जो मोशन है वो भी कंटिन्यूसली कैसा होता है, चेंज होता है. डू यू थिंक सम फोर्स इज कंटिन्यूसली एक्टिंग ऑन द मून? What must be the direction of this force? How would its motion have been if no such force acted on it? Do the planet in the solar system revolves around sun in a similar fashion? Is a similar force acting on them? What must be its direction? From the above activity, if we see example and question, it is clear that the moon to go around the earth, there must be a force which is exerted on the moon, and this force must be expressed by the earth, which attracts the moon towards itself. Similarly, the sun must be attracting the planet, including the earth, towards itself. Hope you have understand today's session. Thank you.